We're doing problem 6 from the fundamentals of chapter 6. I realized I skipped this and someone recently just suggested I should do it. So here we go. So this is not the method of sections, but the method of joints, right, to analyze a truss. So when we do these, remember, we always want to calculate the external forces on our system, right? So we know we have a y on this joint, and actually let's think about these forces. So a y is a good assumption going up, and because it's minus 600 up here, so I'm going to draw ax to the left to counteract the 405 pound force up here. Okay, and then here we have a rocker or roller, right? So there's another reaction right there going up. So let's first solve these. So f of x, right? So it's minus ax plus 450. This one's easy, right? And this tells me that ax is 450 pounds. All right. And then if we do the same thing but for the y, we'll get a couple unknowns, which we'll end up solving for anyways. So we're going to have ay plus cy minus 600, right? You know what? So the reason I'm getting all these, remember guys, is because they're going to help me solve this truss joint by joint, right? So then this will tell me that ay plus cy equals 600. Okay. Now, can't really do anything here. One equation, two unknowns. So I'm going to take a moment about A, right? So if we do a moment about A, let's see. Why did I pick A? Did I pick A? There's two forces pushing or pulling A, so the AYAX. So those don't cause any moment. 600 pounds goes straight down, so it's pushing down on A. No rotation, so no moments. So I only got to deal with this one and this one, okay? So let's do moment about A equals 0, right? So now we'll find, we're going to run into a problem soon. We're going to have cy times 6 feet, right, minus 450 times, oh, there it is, that's the problem. What's that distance? All right, let's leave it blank, right? So we need to solve this distance, right, this h, all right? And they give you a 30-degree angle, right? They're kind of throwing clues at you like, hey, we got to solve this. There's a 30, 60, 90 triangle, right? So we know from geometry, or yeah, back in geometry, 30-60 angle is given to you like this. What else? This would be x, and this would be 2x, I believe. Right? So, you can either go about it this way or just say TOA, so tan 30, right, equals opposite over adjacent, so h over adjacent, and this will give me that 6 is equal to h is equal to 6 tan 30, okay, which is this. I mean, there's my approach to it, to just get a, if you have a calculator, you can just get that answer really fast, right? If you go about it this way, so if you know that off the top of your head, you can say, okay, x is square root of 3 equals 6, and then solve for x, right? Once you do that, you should get, 2 square root of 3, right? And then just plug it in here, and then you get your distances. So you'll get your h, you'll get 2x, and so on, all right? So yeah, so now we have that distance h, so now we can take a moment that 450 pound force causes on A. My dog's going cycle right now. Oh, zoomy time. All right. Yep. Oh my gosh. All right. So 450 pounds times your lever arm H. So that'll be 3.46. All right. And that's it. Those are the only two forces causing this whole structure to rotate about A. So CY, move everything to the right side, isolate CY, and you get 259.8 pounds. Okay, and then, you know, plugging it back up here, you get AY equals 600 minus 259, and that gives us 340.2 pounds. All right. Cool, so now we got the reactions, right? So now we can do joint by joint. All right, so which joint do we go by, do we pick first, right? That's always a question. You want to pick a joint that has a lot of information known about it. So for me, I would pick A, just because there's no angles and it looks pretty straightforward to just calculate, okay? So, you know, there's, you know, method of joints, if you've watched my previous video, they're just long and painful, okay? Because you might know how to do it, but you still have to do all that busy work. All right, so let's do joint A. Okay, so joint A is right here, right? So let's draw the forces in different colors. So we know AY. All right, and all these reactions, right? They're all positive. So all the directions here that I assumed were correct, right? So you draw them just as they are. So we have AY here is 340.2, and then you have AX going this way, and that's 450. Okay. So now these two members that are connected to A are going to be AE. So I'm just going to draw a stick. That's AE, and this is AB. Okay, so we'll call it AB and AE. Okay, so usually I would draw everything in tension. Okay, so away from the joint. But in this case, I already know that 340 is pushing, you know, it's compressing A. So, or acting upwards on A, right? So you know that AE is going to have to counteract that 340, right, to even out. So we know AE is going to go down, right? And this is just because, like, when you do the Y equation, right, you're going to have AE minus AE plus 340.2, right? And that'll just give you that AE is also equal to 340.2. Okay, and if you do the same thing in the X direction, you're gonna be forced to accept that AB is actually in tension. Okay, so again, do the forces in the X direction, right? And you're gonna get minus 450 plus AB equals 0, and then AB is in tension. Right, so let's put T next to it. And then this one was compression. So pounds. All right. Okay. And there was no negative sign in front of them, so I assumed correctly, just because it was kind of given to me. Okay. It might not be given to you elsewhere. All right. So that was joint A. So now we have, let's just color it in. So we have this one, and we have this one. The next one we can do, let's go with C. Joint C looks pretty easy. It only has two joints, or two members, right? So I guess we're gonna go upwards, up the steps here. So joint C. All right. So joint C. Now let's switch colors. Let's go with some maroon, Aggie colors. So we have CY, right? Actually, let's put the value here. CY was 259.8, right? We have 259.8 pushing, going up on CY or on C. Then we have member BC, right? We don't know directions, and member DC, and we know that angle is 30. Okay, and again, before you take any crazy assumption, you know DC is gonna it's going to need to go down, so it's gonna be in compression. The reason why is because when we break these two components, the DCX and DCY components, the DCY component, right, has to counteract this CY force, right? So it has to be going down. That way, 259 minus 259 equals 0. Okay. So then if we do this in the Y direction, we're gonna get minus DC. The DCY component is going to be DC sine 30, right? And then plus 259.8. All right. Hopefully you guys are drawing these or taking notes, because I might have to delete some of this because we're gonna definitely run out of room for this. And those are the only two forces in the Y direction acting on joint C. Okay. Right, because BC is just horizontal, and then you have DCX, or the X component of DC, right? So that's also in the X. So then here we get DC, right? Move everything to the right side. You get, do that on your calculator, 519.6-ish pounds, right? And I drew it in compression. Again, when the arrow is pointing into the joint, that's compression. Okay. So that's another member we just found, right? So DC, so right here, right? And because we just found DC, now we can unlock BC. So we say forces in the X. Also remember that when you're doing method of joints, don't worry about taking a moment equation, because you can't. It's just not possible, right? There's no moment being caused by any of those forces. They're all pushing or pulling the joint. So then we know BC, so if we draw BC going to the right, then DCX and BC are going to add to equal some value, right? It's not going to equal 0. So we know that BC has to go to the left, right? So we're going to have minus BC plus DC cosine 30 equals 0, right? And then just plug this number in here, okay? The 519 times cosine 30, and then BC is equal to 449.9 pounds, or 450, okay? Just put it as 450, and that's also in tension, okay? So you can say roughly 450, right? That might be easier using it going forward. All right. So now we have BC, DC, AE, and AB. All right. Okay, so let's see, where can we squeeze some room? I guess we'll delete the green. All right, guys, so if you haven't written those down, just pause it, write them down, and then follow along. All right, let's see. Let's just erase this. It's been a bit noisy here, because I got my crazy dog just getting zoomies and chewing on I don't even know what. I should probably be paying attention. All right, let's let's look at another joint. Let's analyze, let's see, joint B. All right, let's analyze joint B. So if we analyze joint B, we're gonna have, actually, let's create some more room here. Nice. So we're gonna have BC, and we know what BC is. It's tension force, right? So we're gonna draw BC in tension, right? AB, we already found AB, which was 450 in tension. So actually, let's just put the force here, 450. 450. Okay. What else do we have? We have this weird member that's BE. And then we have a member going straight up, which is BD. And there's this part, you guys will appreciate this because we're going to save a lot of time. If we were to, I don't know, find that angle that BE is making with the horizontal here, right? Let's call it theta, all right? And let's just take an assumption that it's going in tension, okay? And let's say BD is going in tension, because I really don't know any of those, right? If you already know your what are they called? Zero force members, and you can analyze it quickly, then go right ahead and you know that those are going to be zero. But we're going to prove it anyways, because to just really go through the math. All right, so if I were to say f of x equals 0, right? I have minus 450 plus 450, right? Plus, or I guess minus the x component of BE. So it'll be BE cos theta equals 0, right? These two add up to 0, right? And that makes BE equal 0, right? If you just analyze this, right? And then, so we know that from this, BE is equal to 0, okay? And then what happens now, if this is pretty much gone now, right? This makes BD be also 0, because there's only one force that we see here going in the y direction. There's no other force to counteract that force, all right? There's no force going down, right? So if we do that, I mean, just right away it's going to say BD equals 0. BD equals 0. And again, if you do the zero force member analysis, you'll know that those two are just contributing to the structure, not so much the the structural integrity of the beams or the truss itself, but not really carrying any load. All right. So we have BD, BE. So we have these two, right? And then you have a choice. You can either look at joint E, all right, or you can look at joint D, all right. And we've pretty much figured out all the members already, right? The only one that's left is this one right here, ED, okay. And for that, that one can be calculated pretty easily. So let's see, where can I move all this stuff to? Let's just squeeze it out, but down here. Okay. This ain't a fashion show, so just bear with the looks. Alright, so we have joint D, okay? So joint D is going like this. Alright. So we have DC over here. DC, we found that DC was 519.6 in compression. So we're going to draw DC just the way it should be. Alright, so we know that ED has to counteract DC, right? And then we have DB over here, right? Oh wait, but we found that BD was 0, right? So this right here actually doesn't exist, There's no force here, right? So we have two forces opposing each other over here, and you can just, you can prove it, or you can say, okay, ED is equal to DC, right? So we know that ED is equal to 519.6 pounds in compression. Or if you orient your y coordinate in such a way like this, right, and you sum everything in the x direction, right, you're going to have positive ED minus, what was that, 519.6 equals 0, right? And that'll give you your result of ED. And again, if you're worried too much, like if you're super worried about this, remember, we first start out by analyzing the structure as a whole, right, to get those reaction forces, right? Ignore the tension, compression, all that. Just figure out what the reactions are, and then we begin to break it down, analyze the joints in the beginning that have the most information, right? And before you just assume, directions, just try to do some mental work, right? Just look at it first, use some common sense, and then apply your static equilibrium equations, forces in the x and y. All right. And yeah, your professor might give you one, if your exams are maybe 4 to 5 problems, they might give you maybe 1 or 2 of these. Most likely 1, because as you can see, they take a really long time. But yeah, hope this helped you guys. This is definitely the hardest one we've done in the method of joints, right? Because it's got some crazy geometry. But yeah, if you enjoyed this and you have any questions or comments, comment down below. Give the video a like if you enjoyed it. And I'll see you guys in the next few videos.